All right, as we continue with Unit 6, today we're going to talk about taking both decimals and fractions and converting them to a percent. So we'll be talking a lot more about percent in our next unit, but percent means per 100. So a fraction and a decimal and a percent are just three ways of saying the same thing. It's good to know how to convert because sometimes one way is much more convenient to use than another. So just take a look at this example. 10 out of 20 free throws. It's obvious if you make 10 out of 20, it's 50%. So I just wrote 10 out of 20 as a ratio right here. If I were to multiply the numerator and the denominator both by 5, and the only reason I want to do that is if I can make the denominator exactly 100, then the numerator is the percentage. So putting that percent sign is very important. It means per 100 or out of 100. I don't always have to do that, and you can see sometimes it wouldn't be convenient. If the denominator were not a factor of 100, that method would work very well. So another alternative is to convert your fraction to a decimal, which we've already talked about doing, division, long division sometimes, and then per 100, it's like you're multiplying the fraction by 100. So the decimal moves 2 places to the right, so that would give you 50%. Not to be confused with 5%. 5% would be 0.05, and you'd move it 2 places. So you don't want to get those mixed up. Big difference. So first we'll talk about a decimal to a percent. Well, so it's already written in decimal form. Just makes sense to do that second method, which is just move the decimal to the right 2 places, like I've written in the yellow box. So I've filled in a few examples. So you might take a look at those. And then let's just do the rest. If you want to try them on your own and then come back, that's a good idea as well. So if I move this 2 places, I'm going to get 19%. If you just write 19, that's not adequate. You've got to put the percent sign. Here, when I move it 2 places, I get 65.1%. 1 represents 100%. If you did move the decimal, remember when you don't see it, it's understood to be at the end, and if you moved it 2 places, you'd have to fill in a couple of zeros. So 0.3 would be 30%. There's no work needed on these, and 0.03 is 3%. Pretty easy stuff. Notice on all of these that the percentage is the bigger of the two. And I mention that only because later when you go from a percent back to a decimal, sometimes people get confused. Well, I don't know if I move the decimal right or left. Just remember the percentage is always bigger. I would also say that sometimes people think problems like 1 and 4 where you have over 100%, that they don't make sense, but actually they do. Think about, for example, if about going to the movies and getting concession. There's a markup on your the concession food. So you may pay, well, someone I knew in that industry told me once that the markup on the soft drinks was 500%. That means they're charging you, they're making 500% on it, so it's actually 6 times what it costs them. So if their profit is 500%, then it's 5 times what it costs them. So so it does make sense to have something greater than 100%. It's a little tougher to go from fraction to percent. And there's a couple of methods, and the first one is really only convenient sometimes. So if you choose to do just one of these, then I go with method number 2. It works all the time. This one up here, I guess it could work, but it's very inconvenient sometimes. If your denominator is a factor of 100, then if you'll just force it, multiply it by whatever is necessary to get 100, like in this case we multiplied by 10, and you also multiply the numerator by 10, then you'll get 40. So it's 40%. So you can see here, if we multiplied the denominator by 20, we'd get 100. So multiply the numerator by 100, so that is 20%. Remember, percent means out of 100 or per 100. So if you want to try number 12 on your own for a minute, you can do that, and then just pause the video and pick back up. But 20 is a factor of 100, so I'd have to multiply numerator and denominator by 5. You might want to use parentheses instead of the dot there. That's a little confusing. So that equals 15%. So that's pretty simple. Unfortunately, method number 2 is the one people enjoy the least, I would say, and that's just because it requires long division in most cases. So this problem's not a good candidate for method 1 because 8 doesn't divide into 100 evenly. So I would just say, okay, I need to figure out what 7 divided by 8 is. But think about it. It's as if you got 7 problems right out of 8. You know, you'd score pretty well on a test, right? But think about that. So you know if your answer came out to be something like 20%, that doesn't make sense. So I just did the long division, which we're supposed to know from last unit. The decimal point just slid on up. And then once I have, here's the decimal version of 7/8. And then I just shift the decimal 2 places to the right to get 87.5%. Not too tough. This next one, I just wanted to have one that had a little bit more decimals in it. But if you divide 16 into 3, it's easy sometimes for people to divide in reverse. They'll want to switch out the 3 and the 16. You've got to watch what you're doing. Think, if you only got 3 problems right out of 16 on a test, you would not score very well because you got less than a fourth. So you should get under 25%. So if you just kind of think about that, you might not make some mistakes that are easy to make if you're not paying attention. So I just did the long division. You can follow that more closely if you need to. And then I just shifted the decimal 2 places to the right. That's like I'm multiplying by 100. So 18.75% totally makes sense. Don't round. We're going to be exact, so don't round anything and don't stop early. So this one is a little trickier. These are going to take more time than some of the others. It's just like the last one in that I do long division, but this is going to show you what to do when you're converting to a percentage, and it looks like it's just going to keep going on and on and on. So whenever your denominator is things like 7 and 11, if it doesn't go evenly, it gives you some really pretty ugly stuff. So you can kind of learn to start to expect that. So I've got 4 divided by 7. Just going to go ahead and make my decimal in a different color here. And then I know I'm going to need at least 2 zeros here because I'm going to have to convert my my decimal to a percentage. So if I start dividing 7 into 40, that's going to go 5 times. 35. 7 into 50 is 7. That's 49. Add another 0. 7 into 10 goes once. 0. 7 into 30, 4. That gives me a 2. Bring down. So add another 0. 7 into 20 is going to go twice. That's 14. So about now you start kind of going, oh geez, how long is this going to go on? Nothing is repeating, but it just keeps seemingly going on and on and on forever. Well, I would stop at this point, and I'm going to jump over and divide again. If I know that I want an exact percentage each time, if you're not overly concerned with just having all the decimals, my suggestion is, since I know I need to just go 2 places after the decimal, I set it up that way from the start. Catch up to where I was. Oh wait, that's right there. 7 times 7 is 49. And I'd stop right here and pretend that this is just whole numbers for a minute, where you take your remainder and put it over your divisor. Then you can convert it to a percentage. So you're going to shift the decimal 2 places. So I get 57. Oh, I need to write that somewhere else. So I get 57 1/7%. It's tempting for students to get here and they want to shift the decimal, but then they'd have to round and write something like 57.1 or 57.4%, and there's really no reason not to be able to give an exact answer. So anytime I converted one, like even on this last problem, I could have stopped. If I had gone to I could have just put 2 places here. And so I'd have 1, 8, and then I got 12. And then I could just stop and take my remainder and put it over my divisor. Well, 12/16 is 3/4. If you divide top and bottom by 4, and then you shift the decimal, you're still going to get the same result. It's okay if I have 3/4 instead of 0.75. So just an option right there. So I like to just stop dividing as soon as possible. I find that helpful. So here's a couple more examples of the tricky type of going from a fraction to a percent. So you could either follow along with me or pause and try it and then come back. I'm going to go ahead and just keep going with it. So let's say I have 1. I know I'm going to a percent, so I'm just going to go ahead and put my 2 zeros, and I know I'm going to stop there. So pick up my decimal here and start dividing. 6 into 10, 6 into 40. Stopping here because I only need to shift my decimal 2 places, but I've got to put my remainder over my divisor. So I'm going to shift that decimal. So I have 16, and 4/6 is 2/3%. If I kept going on that one, I would have got 6, 6, 6, 6, 6, 6, 6, so it would have been 0.16 repeating. So you never want to write a repeating symbol in a percentage. In fact, when things are repeating, that's why we just try to stick with fraction form. So let's try one more. So 10 divided by 11. Put your decimal 2 places, so 2 zeros, and start dividing. 11 doesn't go into 10. 11 into 100 is going to go, what, 9 times. That's 99. 100 minus 99 is 1. Bring down your 0. 11 into 10 goes 0 times. 0 times 11 is 0. So I get a remainder of 10. So put your remainder over your divisor, shift your decimal, and your answer is 90 and 10/11%. This one, if I'd kept going, would have been one of those decimals that just kind of kept giving and giving and giving. All right, and I believe we have reached the conclusion of lesson 6.3. Have fun converting, and remember, always be exact. Ranger Ron out.